In our first class on the periodic properties of elements, we saw how atomic size, melting and boiling point, and ionization energy shows periodicity. In this class, we look at how electron affinity and electronegativity will show periodicity. Electron affinity is the energy released when a gaseous atom gains an electron to form a gaseous negative ion. The energy released when a gaseous atom gains an electron to form a gaseous negative ion. To describe electron affinity, let's consider the second period of the periodic table. We are taking lithium, nitrogen, and fluorine. Now, lithium has the highest atomic size, Fluorine has the lowest or the least atomic size. Now, this is because of the nuclear charge in lithium and in fluorine. Lithium has a nuclear charge of +3, fluorine +9. Therefore, fluorine has a smaller size because the nucleus attracts the electrons stronger than in lithium. Electron affinity is the energy released when an atom is able to accept electrons to form a negative ion. Lithium does not accept electrons. Instead, it releases electrons. It's a metal. Fluorine accepts electrons, and the energy released there is greater. Therefore, electron affinity increases across the period from left to right. If it does this, that means electron affinity will decrease down the group from top to bottom. Electron affinity increases from left to right across the period and decreases down the group. The important point here to note is electron affinity increases with a decrease in atomic size. Whenever there's a decrease in atomic size or atomic radii, electron affinity increases. So it increases from left to right across the period. Electronegativity is the power of an atom in a molecule to attract electrons. The ability for an atom to attract electrons is known as electronegativity. The most electronegative elements are the top right-hand corner of the periodic table. They are non-metals, while the least electronegative are metals. They are the bottom left-hand corner of the periodic table. As we move from left to right across this period, the atomic radii or the atomic size decreases. This is because of the increase in the size of the nucleus. So as we move from left to right, atomic radius decreases because the nuclear charge increases. This also increases the electronegativity. So the power to attract electrons increases from left to right. Therefore, the power to attract electrons, electronegativity, will decrease from top to bottom. If it increases from left to right across the period, it should decrease from top to bottom down the group.